Hello everyone, welcome to chemistry. Hope all is well. Today we're going to look at isotopes. First thing we'll do, we'll define what isotopes are, then we'll give an example of isotopes and what do they use isotopes for. So isotopes, these are atoms of the same element with the same atomic number but different mass numbers. So atoms of the same element with the same atomic number at different mass numbers. A good example is I've got chlorine. There is chlorine 35 and chlorine 37. So in this case, we can see that the mass numbers, they are different, but the atomic numbers, they are the same. So now, if the mass numbers are different and atomic numbers are the same, it means that the number of neutrons, they are different. So in here, we have got protons that are 17, even here protons, they are 17. Electrons, they are 17, even in this one, electrons are 17. Then the number of neutrons, in the previous lesson, we say we subtract the mass number minus the atomic number. Then even this one, we do the same. So to get this one, for this one, I've got 18 neutrons, and here I've got 20 neutrons. So in an isotope, for isotopes for chlorine, I've got chlorine 35 and chlorine 37. The atomic numbers are the same, the mass numbers are different, and we can see that the number of neutrons, they are also different. So in isotopes, we can also define it as the atoms of the same element with the same proton numbers but different neutron numbers. So all the isotopes have got the same chemical properties. So the chemical properties, they are the same. So this chlorine atom and this chlorine atom will react in the same way because the number of electrons, they are the same. And the number of electrons are the same because the proton numbers are the same. In neutral atoms, the number of protons is equal to the number of electrons. So the isotopes will react in the same way, or isotopes have got the same chemical properties because the number of the atomic number are the same. So we expect chlorine 35 and chlorine 37 to react in the same way because they've got the same number of protons. Then other examples that we can give, we have got carbon. So I've got carbon 12, I've got carbon 13, and I've got carbon 14. So in all these, we're able to see that the number of the mass numbers, they are the same, they are different, but the atomic numbers, they are the same. So here I've got 12, I've got 13, I've got 14. So most of the isotopes, they are named for using their mass numbers. So we call this one as carbon 12, we call this one as carbon 13, we call this one as carbon 14, because their atomic numbers are the same, so we cannot use this. So all these isotopes, they will react in the same way because the number of protons, they are the same. If the number of protons are the same, the number of electrons will be the same. So even in this case, protons 6, even here I've got protons 6, even here I've got protons equal to 6. The electrons, they're equal to 6, even here electrons are equal to 6, here electrons, they're equal to 6. Neutrons, here 6, here the neutrons, they're equal to 7, then here they're equal to 8. So again, we can define it as the same proton numbers but different number of neutrons. So all isotopes of the same element will react in the same way because the number of protons, they are the same. Okay. So we have seen examples of isotopes like for chlorine, which is chlorine 35 and chlorine 37. Now the two isotopes, 35 and chlorine 37. Now these two isotopes in nature, they have got what we call percentage abundances. Now for chlorine 35, we have about 75%, while chlorine 37, we have got 25%. So now in nature, we're going to find 75% of chlorine 35, while we're going to find 25% of chlorine 37. So these masses are the masses that we expect to find on the periodic table. So the periodic table, last time we said each atom has got two numbers, has got the atomic mass and also has got the atomic number. So the atomic mass is also called the relative atomic mass of these elements, are found on the periodic table of elements. Now the relative atomic mass, the symbol is a capital letter A, the small letter r. So for isotopes, there is a formula that we are going to use in order to find the relative atomic mass for that element which contains the two isotopes. So in this case, I've got chlorine, which we need to find the atomic mass because chlorine is able to exist as a mixture of two isotopes, chlorine 35 and the chlorine 37. So in this case, if we want to find the relative atomic mass, which is the mass of one atom, what we do is we say the relative atomic mass is equal to, you get the percentage abundance, we divide it with the 100, then plus, you multiply it with the mass. So this is for the first isotope, let's say it's A, then you add the percentage abundance, you divide it with 100%, you multiply it with the mass. For the next isotope, let's say in this case it's B. So we have got two isotopes. Let's say this one is A and this one is B. So if an element has got three isotopes, we're going to continue that to be our C. If it has got four, we're going to continue to have C and D. But in this case, we have only have chlorine has got two isotopes, 35 and 37. So we're going to use only these two. So the first part is for chlorine 35, the second part is for chlorine 37. So we have said for chlorine 35, the percentage abundance is 75. The 37 is 25. So what we do, we're going to use this to find the relative atomic mass. So because of this word relative, it means this is a ratio that we're going to obtain and it doesn't have any units. So the percentage abundance here, for the first one, this one is 75. You divide it by 100, you multiply with the mass, which is 35. Then you add here the percentage abundance, which is 25. Divide it with 100, then you multiply with the mass. So we are reaching on this part because we only have two isotopes. If we had more than two isotopes, we would have continued. So we are trying to find the relative atomic mass, which is found on the periodic table for an element that has got isotopes, or for an element that has got a mixture of isotopes. So on this part, they can even ask you a question, why do some elements, for example chlorine, does not have the relative atomic mass as a whole number? The answer is because elements such as chlorine, they exist as a mixture of isotopes. In this case, you have got chlorine 35 and chlorine 37. For carbon, carbon 12, carbon 13, and carbon 14. Elements like argon has got 4 isotopes. So when you do this, now we just do simple mathematics here. You can either divide, then you multiply, you can multiply, then you divide, you still get the same answer here. Even if it's the same, we do the same. So after we do this, we do a simple mathematics here. So the first part, when you divide 100 into 75 and multiply by 35, we'll get 26.25. Then you add, when you do for this one, you divide 100 into 25, multiply to 35, you get 9.25. Then when you add the two, you're supposed to get 35.5, which is the atomic mass for chlorine. Okay, so we have known how to calculate the relative atomic mass of a given element using its isotopes. Now, the next thing that we're going to look at is what can we use these isotopes for? So now, these isotopes in medical industries, they are used for in radiotherapy, like the isotopes for cobalt. Then they are also used in the treatment of cancer. They are also used as medical tracers, and they are also used to check the inside of the body. So isotopes are very, very important. They are used for radiotherapy, the treatment of cancer. This is a good example is iodine 131. Again, another isotope of iodine can also be used as a medical tracer and also to check the inside of the body. So these are medical uses. How can we use them now in other industries? So in other industries, we can use them, one, for nuclear weapons, and also we can say to generate nuclear power. So in nuclear power stations, we use isotopes. A good example is uranium-235. They can also be used to check the leaks in oil pipes, and it can also be used to preserve food. So these are the main uses for isotopes in radiotherapy, in the treatment of cancer, as medical tracers, check the inside of the body, in nuclear weapons, also to generate nuclear power, to check the leaks in oil pipes, and also to preserve food. So this question on isotope, they will ask you some of the simple questions that they can ask you. You give the uses of isotopes, you explain why do elements don't have a whole number as the relative atomic mass on the periodic table, and also you can be asked to calculate the relative atomic mass if you're given a mixture of isotopes with their percentage abundances. You can also be asked to calculate the number of electrons, protons, and neutrons in an atom of an isotope. Okay, so for today, we are going to end here on isotopes. I hope everyone is able to answer every question.